new project. The same as before, type of project, empty project, C++. Click next. Typically, I suggest that you keep this check mark on to place solution and project in the same directory. And this is our week 11. We need to talk a little bit about stream states. That's what I plan to do right now. So now it's okay for me to create, except that I want to place this project in location on my drive over here. So this is where I want to place it. I typically copy and paste locations directly to this box without the need to browse for it. All right, let's just say create. View Solution Explorer. Of course, it's empty. So I'll certainly add a new item. And of course, we'll name it main.cpp, which will contain the main function. And we'll place it under source subfolder, which will be the folder that's created automatically. And this would be our realistic version of the main function. I'd like to focus our attention now to the presentation, which is still something that we need to go over, which covers stream states. So just a reminder that this is something that we need to continue to cover. So primarily the coverage of states and using different states and recognizing the states in which our streams are constantly involved with. A lot of it is referred or regarded to formatted input-output. So for instance, when we try to enter an integer and the input that was provided becomes an alphabetical input which cannot be converted to numeric value, we'll place input state and a failed state. So that's where we are going to become very sensitive to this, and we don't want our program to simply fail because of this. We want to be able to handle it. So that's input related errors. And input related errors are indicated and handled by stream states. And then, of course, very important to be able to recognize a recoverable error and recover from it. All right, so this simple example here says what? Let's create a sum. And in this endless loop, let's just say, let's enter an integer. So the user enters an integer, and we add it to the sum, and we tell the user the sum of the numbers entered so far is such and such, and we keep looping. And so as long as the user enters a correct value, everything's okay. Let's just take the sample, okay, and just copy and paste over here. Of course, I need to include IO strings and to say using namespace std to allow mention of standard library namespace in front of the names of these states. So I'll try building it. Oh, I misspelled this. Okay, very good. The program starts to run. Here's the interface. Of course, if I keep adding values, everything's okay. We keep displaying what the sum of the number is. But if I do this and enter some garbage, obviously this garbage will be there will be an attempt to enter it from input to the number over here, and of course it will fail. So after failure, the input will go into failed state, and the behavior becomes this. Okay, it just keeps going and going and going in endless loop. And so my only chance is to actually press Control C to stop running this application, or close it altogether to just abort this run. So obviously this simple looking input is, has a potential of sending this program into an endless loop. So I think that immediately we can improve by just checking the state of the input state and changing this for loop to a while loop. Right? We can say that while sin means while sin is in good state, because in the context of Boolean expression, such as this condition that the loop is trying to evaluate, sin behaves in Boolean context of Boolean expression, which expecting true or false. Sin becomes true if its state is good, or it becomes false if its state is bad. So with this simple change, if I say build, and if I run it again, right, so that this is me running it again. So I do a few good inputs, and then I try to like put bad stuff in there. So there we exit. So at least we find a way to exit out of this situation. So we don't have to struggle endless loop. So this is highly recommended for just a general approach to never use an endless loop around those streams that have states. Rather, perhaps at least check the state once in order to be able to terminate this loop and exit, whether it's a graceful exit or not, but still better than leaving this program in endless loop, which is obviously very frustrating experience. Okay, so this is the possibility here. So back to the example, right? So this is the next slide. Basically shows us that hey, if you do something, this will be if non-numeric input is given, the loop will terminate. So this is fine. But interestingly, the sin will be in a failed state. So let's just do a very quick demonstration of this once again, possibly using a small drawing of what is happening when it goes into a failed state.